This video is for the grade 12 learners who will be writing their term 1 math investigation based on trigonometry, specifically double angles. So you guys know that the way in which investigations are tested is that you are usually given the investigation before your teacher can teach you the section. So they expect you as a learner to go home, do a bit of research about the topic, see what the topic is based on, see what the new identities are going to be, so that you have somewhat of a knowledge of what the topic will be about. So investigations are very entry level. It's tested in the most basic way that will help you to deduce what double angles are and how we use them. So this particular investigation that I'll be going through is a KZN paper, and this is from the year 2022. So this was written on the 25th of Feb 2022. It is for 50 marks and it was 1.5 hours long. Let's just have a look at the instructions. They say read the following instructions carefully before answering the questions. This task consists of 5 parts and is spread over 5 pages. Answer all questions. Write your responses in the spaces provided for that purpose. Scientific calculators may be used unless indicated otherwise. So extremely important that you guys, not just for your investigation but for this video as well, before you get started, please make sure that you have a pen and a book that you can work in, as well as your calculator on hand, so that we can work through this together. Okay, instruction 5 says no information sheet is needed in answering this task. As I've mentioned, it is very entry level, very basic. So they do not provide an information sheet, and write neatly and legibly as you always should. So we've got part 1, that is the introduction. And 1.1 says, is it correct to say that sine 2x is equal to 2 sine x? Now that space on the right hand side should be for a simple yes or no answer, but they say motivate your answer by choosing any 3 values of x and completing the table below for those values. Round your answers off to 3 decimal places where needed. Now you are given a choice. It's up to you which 3 values of x you'd like to work with. I would suggest stick with relatively small values. For me, I would just go with 10, 20, and 30 degrees. That seems simple enough. I'll also keep my angles acute. They are all less than 90 degrees so that I don't have to reduce them along the way. Okay, so let's fill that in. Okay, here we have it. And focusing on this next column, we've got sine 2x. Now they say round your answers off to 3 decimal places where needed. Since they've mentioned that, let's just keep 3 decimal places throughout. Now, for the sake of working out, I'm just going to show you guys how we do this. Normally, when you press your sign button on your calculator, it automatically opens up a bracket. So how do we fill in the 2x? 2x is basically 2 times whatever x is. So in your bracket, you're going to have 2 times 10 degrees. That is essentially what 2x means. 2x is a double angle. I'm just going to write down the rest of it and then we can calculate afterwards. So the second one is going to be 2 times 20 degrees and thereafter 2 times 30 degrees. Bear in mind, you guys do not have to use the same values that I'm working with. You could use any 3 values of your choice. Now I'm going to start off by substituting. So I've got I've got sine of 2 times 10 degrees. And remember, they had asked us for 3 decimal places, so this gives me a 0.342. Okay, I'm going to go ahead and do the next 2. Feel free to pause the video and get your answers. Okay, so here's what I got. For sine of 2 times 20, I've got 0.643. And bear in mind, for that one, it was actually 6427, which is why I rounded off and it became 43 at the end. Sine of 2 times 30 degrees, that gave me 0.866. Going on to the next column, we notice that we now have 2 as the coefficient of sine. So this is what it's going to look like. It's going to be 2 sine, and inside the bracket we'll have 10 degrees. So the placement of that 2 is very important. In our second column, 2 is the coefficient of x. But in the next column, 2 is the coefficient of sine. So 2 has different purposes, different functions according to its placement. Okay, the next one would be 2 sine 20 degrees. Thereafter, 2 sine 30 degrees. I'm going to go ahead and calculate this. Feel free to pause the video and get your answers. Okay, so here are my values. For 2 sine 10 degrees, I've got 0.347. Notice that these are not the same. We can clearly see sine 2x here and 2 sine x, they are not equal to each other, even though those values look so similar. And this is actually why they asked you to get 3 decimal places. Because had we taken 2 decimal places, both answers would have been 0.34. But that would have actually been 0.35, but they'd be so similar to each other that we would think they are the same, and we would be mistaken. So by taking more decimal places in this case, which we took 3, we can see that they are not equivalent. For the next one, I had 0.684, and again, that is not the same as 0.643. And then for 2 sine 30 degrees, I have 1, which obviously is not the same as 0.866. So now we can go back to the top. Is it correct to say that those are equal to each other? No. So it is not correct to say that. So not really necessary for you to write this, but I am just going to put this here so you guys can take note. Sine 2x is not equal to 2 sine x. And the reason why they have this kind of question in here is because this is something that's worthy of you taking note of, especially when it comes to you actually doing the section, and when you're going to start doing questions like proving left hand side is equal to right hand side, simplifying, etc. You need to know that sine 2x is completely different from 2 sine x. Sine 2x is a double angle. And I just want to make a note of that for you guys, right? This here, that is a double angle. And once you guys learn about this section in school, you will come to learn that double angles have their own expansions. So sine 2x has a specific expansion, which I'm not going to mention here. Let's not complicate it. Okay, let's go on to 1.2. They say, is it correct to say that cos 2x is equal to 2 cos x? Now, judging from what we've just done with the sine, and we said that no, they are not equal to each other, we're expecting this to not be equal as well. And they say motivate your answer by choosing any 3 values of x and completing the table below for those values. Round your answers off to 3 decimal places where needed. So here I'm going to go with the same 3 x values as before, 10, 20, and 30 degrees. Next, we're going to work on the column that has cos 2x. So that is going to be cos of 2 times 10 degrees, cos of 2 times 20 degrees, cos of 2 times 30 degrees. Okay, I'm going to go ahead and calculate this. Feel free to pause the video and get your values. So here is what I have for the first one. I've got 0.940. It was actually 0.9396 if I'm not mistaken, but that changed the 39 to 40. The next one, I've got 0.766, and for the last one, it was just 1/2, which is 0.5. If you want to get it to 2 decimal places, obviously you can just put 2 zeros after the 5. Okay, let's go on to the next one. We've now got 2 cos x, so that's going to be 2 cos 10 degrees. then 2 cos 20, and 2 cos 30 degrees. Okay, so here are my values, and we can clearly see that the values in both columns are not equal to each other. So to go back up to the question, is it correct to say that cos 2x and 2 cos x are equal to each other? No, they are not equal to each other. So they are not equal to each other. And also, you guys take note that cos 2x here, when 2 is the coefficient of x, that is when it is a double angle. And also, since cos 2x is a double angle, it would have its own expansion. It actually has 3 expansions. If you've already started with the section, you would know that, okay? You'd be familiar with that. But that is not really necessary at the moment. Let us go on to part 2, investigating. So 2.1 says, consider f of x is equal to sine 2x. And it looks like we have to draw a graph. So you may be wondering, why are they bringing trig functions into this? The reason is because every expression can be graphed. Every expression in maths can be drawn. Okay, it actually is a function. We can make it be a function. And sine 2x as well. Now, you guys may have actually drawn this graph last year without realizing that it's a double angle, because that was not part of your, double angles were not part of your syllabus last year. So you were not familiar with them, neither did you know of them. But before I go on, I just want to show you that this graph is in the format y is equal to sine bx. And b has a specific function. The period gets divided by b. Now, for an ordinary sine graph, for a basic sine graph, sine x, the period is 360 degrees. So if the b value here is 2, it means that the period of this graph is now going to be 180 degrees. That means that our graph is going to be a little compressed. Instead of taking 360 degrees to make one wave, because remember the sine graph is a wave, it now only takes 180 degrees. So it's taking half that length. 2.1.1 says, complete the table below, rounding your answers off to the first decimal place where needed. So we got to put this in our calculators. They say first decimal place, so they actually want 1 decimal place where needed. So we can fill in the first, let's go with the first 2 values together, and thereafter I will pause the video and fill in the rest of the table. Now, just to write it here to show you how we are substituting, it's going to be sine of 2 times negative 90. Okay, so let's punch that into the calculator. That is going to be 0. Now, you guys remember that when it is a double angle and it looks like this, 2x, where the 2 is the coefficient of x, the 2 goes inside the bracket. The 2 is multiplying with the angle. Let's try the next one. Sine of 2 times negative 75. That is giving me negative 1/2, and then as a decimal, it'll be negative 0.5. Okay, I'm going to continue like that in the same manner. They mentioned that they want 1 decimal place, so that is how I'm going to work. Okay, feel free to pause the video, get all of your values, and press play once your table is filled in. Okay, so here are my values, and I've got everything to 1 decimal place as requested. Now we can go on to 2.1.2. They say now use the table to draw the graph of f of x is equal to sine 2x on the system of axes below. So we need to plot this. One thing I noticed though is that they didn't actually fill in the values on the x-axis. So let me just do that. Let's give ourselves a scale. It's best to actually work with the scale that they're using. They're going in terms of 15 degrees. So let me just start off by filling in those values, then we can plot. Okay, there we have it. Now we can just work left to right as we've got it here. When x is negative 90, y is 0. So that is actually an x-intercept. When x is negative 75, y is negative 0.5, negative 60, and negative 0.9, negative 45, and negative 1, negative 30, and negative 0.9. And obviously we are estimating where negative 0.9 is going to be. It should be slightly above negative 1. Negative 15 is negative 0.5, 0 and 0. The graph goes through the origin. 15 degrees and 0.5, 30 degrees and 0.9, 45 degrees and 1, 60 and 0.9, 75 and 0.5, 90 and 0. So all of these points forms our sine graph. And you guys can see, okay, we're going to join the points just now, right? But I just want to mention that you guys can see that the span of this graph, the domain of this graph, it is taking 180 degrees to make this one complete wave. So that was the effect of this b value being 2. It divides the period by 2. But that's something you guys actually know from grade 11, okay? So it's something that you should take note of. So here is my graph. I have joined through all of the points, and the last thing would be to label this graph. So somewhere next to it you are going to write f or f of x. We're now going on to 2.2. They say consider f of x is equal to 2 sine x cos x. And you guys, that is actually the expansion for sine 2x, okay? So sine 2x is equal to 2 sine x cos x. This is something that you're going to learn once you start this section. So if you're familiar with it, you'd already know that they are equivalent to each other. But because it's an investigation, and they expect you to come to this realization after working through it. So for now, we can just pretend as if we don't know that, because also chances are that you are not on the section yet. So it's something that you don't know. So let's just work. They say complete the table below, rounding your answers off to the first decimal place when needed. Now we are going to substitute into this. And just to show you how we're going to substitute, let me show you maybe the first two values, okay? Then I'll let you do the rest. We're going to have 2 sine, and wherever we have x, we are substituting that value. So that is what your first substitution is going to look like. On your calculator, you're going to have 2 sine, negative 90, close the bracket, then press cos, and then negative 90 in the bracket, close the bracket, and you should get a value of 0. Next, we are going to replace that negative 90 with negative 75. That gives me negative 0.5. Okay, so that on your calculator would have been 2 sine negative 75 cos negative 75. So you guys are going to continue in this manner, substituting all of those values and writing down what the y values are going to be. Feel free to pause the video, complete the rest of the table, and press play when you are ready to check your values. Okay, so I'm going to pause this, fill in the rest of my table, and then we can check in afterwards. So here are my values, and something that you guys notice is that all of the values in this table are exactly the same as the previous table, which means that the graph is going to look exactly the same as well. So 2.2.2 says, now use a table and draw the graph of f of x is equal to 2 sine x cos x on the system of axes below. Again, they have not filled in the scale on the x-axis, so I'm just going to go ahead and do that. working in the same way as they have it in terms of 15 degrees. There we go. Now you guys are going to then plot these points. So we've got negative 90 and 0, negative 75, negative 0.5, negative 60 and negative 0.9, negative 45 and negative 1, negative 30 and negative 0.9, negative 15 and negative 0.5, 0 and 0. Then we have 15 and 0.5, 30 degrees and 0.9, 45 degrees and 1, 60 degrees and 0.9, 75 degrees and 0.5, and 90 degrees and 0. Now all that's left to do is just draw a line through these points. So it should look something like this. And lastly, we are going to label the graph. So somewhere next to it, we're going to say f or f of x. You guys, it should be the exact same graph as the one that you had before. (2.3) says write down your observations from 2.1 and 2.2. So hey, since these two graphs are exactly the same, it means that those equations are equivalent to each other. It means that sine 2x, so here sine 2x is equal to 2 sine x cos x. And I actually mentioned that to you before I drew this. So this is what we're going to mention. We are going to conclude that sine 2x is equal to 2 sine x cos x. So this actually has its own proof, which you are going to learn once you start the section in school. But for now, we've just used functions to show that they are the same. That if we plot both sides, their functions should look exactly the same if they are equal to each other. So that is what we've done. We're now going on to part 3, that is deduction and application. Do not use a calculator when answering part 3. Okay. 3.1 says apply the compound angle expansion. So sine x plus y is equal to sine x cos y plus cos x sine y. Now if you're seeing this for the first time, I know it can be a bit daunting. If you've already done the section, then you know this expansion. And when we compound angles in trig, we are just splitting up an angle in terms of two other angles. For example, if we were to have 50 degrees and split it up as 20 plus 30, that would be compounding it, and we can further expand it. So this is what compound angles are. And they want you to apply this expansion to sine 2x and simplify your answer. Now, they have said sine 2x is equal to sine x plus x. Why are they allowed to say this? It's because x plus x does give you 2x. So that is perfectly fine. Now they want you to apply this to that. Meaning that we need to expand what we've got here according to that right-hand side. So the thing is, if we look at the order, it is sine of the first angle times cos of the second angle. So our first angle here is x, and our second angle is also x. Then we've got a plus, and then it's cos of the first angle times sine of the second angle. So cos of the first angle here is x, sine of the second angle is x, sine x. Now, at this point, you need to realize that these are actually like terms. They are exactly the same thing. Cos x times sine x is the same as, this is the same as sine x times cos x. And how we know that is because in maths, when you are multiplying two values together, example, if you're multiplying a times b, it's equal to b times a. So we can actually swap those two around. And if we swap them around, we realize that we have like terms. So if we gather them, we now have 2 sine x cos x. And that is exactly the rule that we have just figured out above. If you notice here, That is the exact same rule. This is using a compound angle to prove it. Let's go on to 3.2. They say expand each of the following using your answer from 3.1. So this is our answer from 3.1, and we need to expand it accordingly. Now we've got sine of 100. So the first thing I'm going to do is I'm going to write it in terms of this left-hand side, where I'm going to write it as sine of 2 times 50 degrees. Okay? And now I'm going to write the right-hand side. The right-hand side is going to be 2 sine 50 cos 50. So all we're doing is we are splitting up the angle that we have as a double angle. The next one we have is 46, so that should be sine 2 times 23. And using the expansion, it's going to be 2 sine 23 cos 23. And if you don't believe that this is correct, you are welcome to put it on your calculator and see that both sides are equivalent. We now got sine 4 theta. So we can write that as sine 2 times 2 theta. And now let's expand. It's going to be 2 sine 2 theta cos 2 theta. I also notice another double angle in here. The sine 2 theta is another double angle. Not sure if they want us to expand that as well, but seeing that it's 1 mark, I'm just going to stop there. Let's go on to 3.3. Write each of the following expressions as a single trig ratio. Notice what they've done here. They have given you that in the format of 2 sine theta cos theta. And we know that it should equal to sine 2 theta. So they say as a single trig ratio, meaning that they don't want you to have both sine and cos in it. So we are going to write that as sine 2 times theta, where we identify theta being 90 degrees. That is going to be sine 2 times 19. Or 2 times 19 is 38, so we can just write it as sine 38 degrees. Okay. The next one, theta here is 4, so we have 2 cos theta sine theta, which is going to be sine of 2 times 40 degrees. That is just actually equal to sine 80 degrees. Now for the next one, it is not as simplified as it should be. We've got sine 25 degrees, but we've got cos of 155. Now you guys know that in maths, in trig, we don't like angles that are bigger than 90 degrees. We want them to be acute angles, and one way of getting it to be an acute angle is to apply a reduction formula, an appropriate reduction formula. 155 lies in the second quadrant, so let's use 180 minus. And we get 180 minus 25, which is good. It shows that we're on the right track because we need those angles to be the same. Then 180 minus is in the second quadrant where cos is negative. So that's going to be negative cos 25. And when I multiply these two, I just want to pull out the negative to the front. So it's going to be negative sine 25 cos 25. Now there's a problem with this. We are missing the 2 in front. Normally the expansion should have the 2 in front, okay? But the 2 is missing here. This is actually a common thing that they like doing, where the 2 is missing, but we can include it by multiplying by 2 over 2. And essentially, we are not exactly altering the expression because 2 over 2 is 1. So what's happening here is we can take that 2 and place it in front. Remember, there was a minus. So we have 2 sine 25 cos 25 all over 2. And my numerator, I can simplify. That's going to be sine of 2 times 25 all over 2. Now I know that the space is quite small for all the working out that we need, and it's also 2 marks, but I'm just trying to show you every single step without leaving anything out. They've probably only allocated space for the 2 marks that you're going to get, the 2 steps that you need. But this is just to break it down quite nicely and show you. And we have negative sine 50 all over 2. So if you are not sure, you can actually plug in sine 25, cos 155 on your calculator. It gives you negative 0.383. And then let's plug in negative sine 50 over 2, and it gives us the same value, negative 0.383. So those two are equal to each other. All right, let's go on to part 4. So part 4 is based on cos 2x. So we are done with the double angle of sine. We're now going on to the double angle for cos. And 4.1.1 says, complete the table below, rounding off your answers to the first decimal where needed. Now, you guys know how to do this. We're going to work in the same way that we worked with sine. It's just that we are going to press the cos button on our calculator instead. So you guys can take a minute, fill in your table. I'm going to pause the video and fill in mine, and then once you're ready to check your values, you can press play. So here are my values, again to 1 decimal place. Then in 4.1.2 we need to sketch this graph, so I'm just going to start off by filling in the values on the x-axis first. And now we can plot those points. So here are all of my points plotted, and the next step would just be to join these points. So here we have it, and this graph is called f of x, so we're just going to label. Now 4.2, we are given f of x is equal to cos squared x minus sine squared x. 4.2.1, complete the table below, rounding off your answers to the first decimal where needed. So I'm going to work exactly as I did before. I am going to substitute, get the values. I'm also going to draw the graph and plot it. So I'm going to do all of that first while the video is paused, and then when I press play, you guys can see what my graph looks like. So here is my table with all the values. Here is my graph. And an observation is that this graph is exactly the same as the previous one that was plotted. So 4.3 says, write down your observations from 4.1 and 4.2. Since both the graphs are equal to each other, we can equate their equations. The first equation was cos 2x. So we're going to say cos 2x, and that is equal to the next equation, which is cos squared x minus sine squared x. And now we are going on to part 5, which is the last part of this investigation. It says deduction and application. Do not use a calculator when answering part 5. 5.1 says apply the compound angle expansion. So this is what we are applying. Cos x plus y is equal to cos x cos y minus sine x sine y. To cos 2x and simplify. Now, we've got cos x plus x, and we need to expand it according to this right-hand side. Firstly, notice that it's cos of the first angle times cos of the second angle. Applying that here, cos of the first angle times cos of the second angle, there is a minus in between, and then it is sine of the first angle times sine of the second angle. So our first angle is x, and our second angle is x as well. Now we notice that we've got cos x times cos x, which is cos squared x. I think I've mentioned minus, but I wrote a plus by mistake. Let's correct that. Then we've got a minus. Sine x times sine x will be sine squared x. And then 5.2 says complete the square identity. Sine squared x plus cos squared x is equal to, you guys know this from last year, it is equal to 1. 5.3 says use the identity in 5.2 and rewrite cos squared x minus sine squared x in terms of sine only. Whenever they ask you for something in terms of sine only, what they mean is that they want only sine in your answer, which means that we no longer want this cos squared x. And something you guys know from previous years is that this identity can be manipulated. If we want to get rid of cos squared, we can keep cos squared x on the left hand side and manipulate this by taking the sine squared x over to the right where it becomes negative. That is what we're going to do. We're now going to replace cos squared x with 1 minus sine squared x. Next to that, we've got the minus sine squared x. And if we gather like terms, we've got 1 minus 2 sine squared x. That cannot be further simplified, so we're going to stop there. For 5.4, it says use the identity in 5.2 and write cos squared x minus sine squared x in terms of cos x only. So now we want only cos x in our answer. So our aim is to get rid of the sine squared x. And going back to that identity, we know that it can be manipulated. To get rid of the sine squared x, we can replace it with 1 minus cos squared x. So let's do that. Now the problem here is that there is a minus. Not so much of a problem, but you must remember, when you're replacing sine squared, please replace it in a bracket, because that negative will have to multiply into the bracket with both terms. When it multiplies in, we're going to get minus 1 plus cos squared x, and gathering like terms, you've got 2 cos squared x minus 1. That cannot be further simplified, so we're going to stop there. Okay, so 5.5 says simplify each expression to a single term. We have cos squared 19 minus sine squared 19. This is in the format of having cos squared x minus sine squared x. And from 5.1, or even above that, 4.3, we know that it's equal to cos 2 times x. So applying that here, x is 19. This is the same thing as cos 2 times 19, which is basically cos 38 degrees. Now we've got cos squared 19 plus sine squared 19. The fact that we got the plus in the middle, think of 19 as theta. Cos squared theta plus sine squared theta is equal to 1. Then we've got 2 cos squared 50 minus 1. That is in the same format as this expansion, which is equal to cos 2x. So cos 250. That is going to be cos of 100. 1 minus 2 sine squared 50 is also equal to cos 2 theta. Where theta is 50 degrees, that is also equal to cos 100. And if you're not sure and you feel like you're on the wrong track, then you can always just plug it into your calculator, check that you're doing the right thing, and the decimals should be equivalent to each other. Next, we've got 6 cos squared theta over 2 minus 3. The first thing I notice is that 3 is common. Let's pull out 3 as a common factor. That's going to give us 2 cos squared theta over 2 minus 1. And I want you to note it that this in the bracket is in the format of being 2 cos squared x minus 1. So that should be equal to, keeping the 3 in front, right? That is going to equal to cos 2 times whatever the angle is. And the angle in this case is theta over 2. So what happens when we take 2 and multiply with theta over 2? The 2's cancel out. So this is just 3 cos theta. Now 5.6, and this is the last question of this investigation. It says it is given that cos 32 is equal to t. Without using a calculator, express cos 16 in terms of t. Okay, so here's how we're going to do this. cos 32, let's write it as a double angle. It would be cos of 2 times 16. This will allow us to introduce the 16 that we need. And then I am going to choose from what we've realized. Cos 2x has 3 different expansions, okay? Here's the one expansion, which is cos squared x minus sine squared x. Here is the next expansion, 1 minus 2 sine squared x. And the third expansion is 2 cos squared x minus 1. This is the expansion that I'm going to go with because I need to get cos 16 alone. So I'm going to go with 2 cos squared x. In this case, x is 16. Don't necessarily need it in a bracket. Minus 1. And on the left hand side, I'm replacing cos 32 with t. All I have to do from here is make cos 16 the subject. So to do that, I'm going to take the negative 1 over to the left. It's going to add. I'm left with 2 cos squared 16. I'm going to divide both sides by 2. I'm left with cos squared 16 on the right. And then I am going to square root both sides. And where I have those values, I'm going to put a plus or a minus in front. On the right hand side, the square root and the square cancel out, and I've got cos 16. And from the left hand side, I've got plus or minus t plus 1 all over 2. So that should be your final answer. So we have actually completed this entire math investigation, and hopefully if you are writing on the same topic, double angles, hopefully yours would be similar to this. They generally do not change the format that much from year to year because it obviously is the same concepts that are being tested. But if you work through this and you've understood it, then you should be fine for your investigation. All the best.